In section 5.5, we're going to learn about the properties and laws of logarithms. We're going to use these properties to simplify and to evaluate expressions. So let's learn some basic rules of common logarithms and natural logarithms. First of all, log of v is defined only when v is greater than 0. And that's this one here. And that just deals with the domain. Remember back in the last section when we looked at the domain of the log of v, it was all of the positive real numbers. Okay, and then number 2 here, number 2 says, and this is sort of the equivalent with the natural logarithm. So I'm just going to go over 1 here. It says that the log of 1 is equal to 0. And that's something you can memorize. And the reason for that is because if you look at your base of 10 raised to the 0 power, well, anything raised to the 0 power is always 1. And then, of course, the log of 10 is always 1. And that's because 10 raised to the 1 is equal to 10. All right. And then your third one here is log of 10 raised to the k is equal to k for every real number. And again, that's because you have this base of 10 raised to the k would be 10 raised to the k. So it's going to be k is equal to k in that case. And then and the fourth one, 10 raised to the log v equal to v is equal to v for every v greater than or equal to 0. And again, you could write that in logarithmic form to understand this. So you've got your 10 raised to the log v is equal to v. So if you think, if you have something like 10 squared is equal to 100, you know that the equivalent expression for that is the log with your base 10 of 100. So your 100 goes here, is equal to 2. Okay, and so the same thing happens when you're over here. You just have to remember that this is an exponent. So you've got your log here, your base 10, so that takes care of this piece, of v is equal to, and then your exponent would go here, log v. Okay, and so in that case, then you understand that we would get this here. Okay. All right, let's look at the example that we have. We're going to use these basic properties to solve the equation log of x minus 3 is equal to 1. Okay, so we've got equal to 1 here, a log equal to 1. So if you go up and you look at step 2 or property number 2, you see there that you have it's equal to 1. Well, that means we know that the log of 10 is equal to 1. All right, so what does that mean about these guys? If they're both equal to 1, then we know that 10 has got to equal x minus 3, which means that x is equal to 13. Okay. Now, if you don't remember that property, but you do remember properties of logarithms, then you could just simply take this and say, okay, 10 raised to the first power is equal to x minus 3. And, of course, that means 10 is equal to x minus 3, and you add 3 to both sides, and you get 13 is equal to x again. Right? So then we have the product law of logarithms, and the product law that says if you have a single logarithm here, okay, so condensed, and you have a product, and if you want to expand that logarithm, then you can write it as log v plus log w. And the same way with natural logarithms. So let's look at some examples with that. Let's say we're going to use the product law and we're going to evaluate each one of these. So what we know right now is the log of 3 is 0.4771 and the log of 4 is 0.6021. And we want to find log 12. Well, we don't know what log 12 is. We can't use our calculators. So what we do know is that log, I'm going to come down here and do A. We know that the log of 12 can be rewritten as the log of 3 times 4. And by the product law, then we know that that can be rewritten as a log of 3 plus the log of 4. So that's helpful because I know what the log of 3 and the log of 4 are. So if I put in my 0.4771 for my log 3 plus my 0.6021 for that, then I end up getting that the log of 12 is about 1.0792. Okay, and let's look at our second one. In our second one, we've got, this time we've got that the log of 3 is here. We've got the log of 3, or the natural log of 3, and the natural log of 6, and I want to find the natural log of 18. Not using our calculator, so I'm going to rewrite the natural log of 18 as 3 times 6, natural log of 3 times 6. And so then, of course, that can be rewritten as natural log of 3 plus the natural log of 6. And then plugging in values there. And just simplify that, and I get 2.8904. Okay? Okay, and then we have the quotient law of logarithms. Now, the quotient law says that if you have a single logarithm and if you have a quotient there, then that can be rewritten, expanded as the log of v minus the log of w. And the same works when we have natural logarithms. And now let's apply that to a problem. Let's say that we have, we would like to find, or actually we know that the log of 40 is 1.6021 and the log of 8 is 0.9031. We want to find the log of 5. So log of 5, okay, I can't use my calculator, so I need to write that using 40 and 8. Well, I know that 5 is 40 divided by 8, so I'm going to use that. And then if that's the case, then using the quotient law, then I can say log of 40 minus the log of 8. And then I just plug in the values that I know, 1.6021 minus 0.9031. And I simplify that, and I get 2.8904. Okay. And then we have the power rule. Okay, so the power rule says that if you have a single logarithm with k as your exponent, that k can be taken out front, and so it can be rewritten as k times the log of v. And the same works again for natural logarithms. Same properties. So let's use that here. We're given that the log of 25 we're given that the log of 25 is 1.3979, and we want to find the log of the fourth root of 25. Okay. So for A, then what I'm going to do is take that log fourth root of 25 and rewrite it as the log of 25 raised to the 1/4 power. Now, if that's the case, then power law says that I can take this 1/4 and put it out front. 1/4 times the log of 25. Okay, so I know what the log of 25 is, and that is going to be 1/4 of 1.3979. And if I take a fourth of that, then I get 0.3495. Okay, and then let's try the second one. We've got the natural log of 22. Actually, square root of 22 is what we're trying to find. And we know that the natural log of 22 is this. So I can rewrite that as the natural log of 22 raised to the 1/2. I will use the power law to bring that 1/2 out front, say natural log of 22. And then I know that the natural log of 22 is 3.091. So, okay, and then if I simplify that, then I get 1.5455. Okay. And now we're going to move on to some different problems where we're actually, these get a little more complicated. Instead of expanding them, what we're looking to do is write them as a single logarithm this time. Okay, so you notice how I have the log, several logs here. I want to rewrite that so that I have the log of one expression here. Okay, so that's our goal. So the first thing I would do is start with the power law and see if you can basically sort of undo the power law. And I notice that I have a situation right here that can go back there. So if that's the case, then let's say, okay, well, I'm going to rewrite this as log 8x. And you need to make sure you show each step here. If you don't, then you're likely to mess up. x cubed, so that's the change this time, minus log of 2x squared. Okay, so from there, let's start from the front and see what we can simplify. So you're adding there those logarithms, which means that we can sort of go and undo that product law. Okay, so that means that that can be rewritten as a single logarithm, and make sure you're underlining each step, and we're multiplying those two. So I'm going to 8x times x cubed, and that's using the product law. And then I'm going to keep this log here, 2x squared. And now let's just use a step to simplify. That's going to be the log of 8x to the fourth minus log 2x squared. Okay. Now once I'm there, then we've got subtraction. So subtraction allows me to get these two together, writing a single log using division. So 8x to the fourth over 2x squared. Okay, and now from here I just need to simplify, and I've reached my goal, which is writing it as a single logarithm once I simplify. So it's 4x squared is how that simplifies, and that's it. All right. Now the last one, we're just given a logarithm and we're asked to simplify. Okay, so we have a lot going on here. So first of all, let's say that we go through and simplify each of the expressions. Okay, and there are several different ways you can approach this, but I'm going to approach it by actually taking this, leaving this 2 here for now, and I'm going to rewrite this so that I don't have any radicals. I'm going to rewrite those radicals as exponents. So that's going to be m to the 1/4 over m, and I notice that I can do some simplifying there in a minute, right? Plus the log, and the square root of 100, I know is 10, and then I can take out an m, and I'm left with a m in there. Okay, so I said I was going to do this without square roots, so this m right here can be rewritten as, unless we're going to have to do this in another step, m to the 1/2. Okay, so basically what I have is m times m to the 1/2, and at the same time, let's go and take this 2 and put it here. Okay, all right, so in the next step, then what I have is the log of m to the 1/4 over m, which, let's go ahead and simplify those. Okay, let's make that a little simpler. So if I have 1/4 of m on top and a whole m on the bottom, then I have more on bottom. And how much more do I have on bottom? I have 3/4 more on bottom. So basically that would give me 1 over m to the 3/4. But let's say I want it in the numerator, then I'm going to rewrite that as m to the negative 3/4 to put it in the numerator. Okay, all of that raised to that second power, plus the log of 10m, and now I have m and a m to the 1/2 power. So if I add my exponent, so that exponent's 1 plus the 1/2 gives me 1.5 or 3/2. Okay. All right, so from here I can take this logarithm, and power to a power law says that that's going to give me m to the so that's going to be negative 6 over 4, so negative 3/2. Okay. All right, plus the log of 10m to the 3/2. Okay, so now that I've got it simplified there, then I can go ahead and, since I have addition, 2 logarithms, put it together as a single logarithm, and I'm multiplying those two, m to the negative 3 over 2 times 10m to the positive 3 over 2. Okay, and when I simplify that, then if I add my exponents for these two, since I'm just multiplying that stuff, I add my exponents, I get an m to the 0 power. Okay, m to the 0. M to anything to the 0 power is just 1. So those basically sort of cancel each other out, and I'm left with the log of 10 here. And we know that the log of 10 is just 1. And so all of that simplifies down to 1. And that's all I have for section 5.5.